Hello everyone. In this video, I will show how to build neural network with Python and how to explain deep learning to the business using visualization. Deep learning. It is a type of machine learning that imitates the way humans gain certain type of knowledge, and it got more popular over the years compared to standard models. While traditional algorithms are linear, deep learning models, generally neural networks, are stacked in a hierarchy of increasing complexity and abstraction. Therefore, the deep in deep learning. Neural networks are based on a collection of connected units, that is neurons, which, just like the synapses in a brain, it can transmit a signal to other neurons so that, acting like interconnected brain cells, they can learn and make decisions in a more human-like manner. Today, deep learning is so popular that many companies want to use it, even though they don't fully understand it. Here, I will present some useful Python code that can be easily applied in other similar cases. In particular, I will go through experimental setup, artificial neural network, deep learning with deep neural network, model design with Tensorflow, visualization of neural network with Python, model training and testing. Now, environmental setup. In this, there are two main libraries for building neural network, that is TensorFlow and PyTorch. TensorFlow developed by Google and PyTorch developed by Facebook. They can perform similar tasks, but the former is more production ready, while the latter is good for building rapid prototype because it is easier to learn. Those two libraries are very useful and sometimes necessary for processing big data set. In this, I am going to use TensorFlow and Keras, a high-level module way more user-friendly than pure TensorFlow and PyTorch. The first step is to install TensorFlow through the terminal, that is pip install TensorFlow. If you want to enable GPU support, you can read the official documentation or follow this guide. After setting it up, your Python instruction will be translated into Coda by your machine and processed by the GPU. So your model shall run incredibly faster. Now, we can import our notebook, the main modules from TensorFlow Keras, and start coding. From TensorFlow.keras, import models, layers, backend SK, that is import matplotlib.pyplot as PLT, import sharp. Now, artificial neural network. Artificial neural network are made of layers with an input and output dimension. The latter is determined by the number of neurons, that is also called nodes. A computational unit that connects the weighted inputs through an activation function. Activation function which help the neuron to switch on or off. The weight, like in most of the machine learning algorithms, are randomly initialized and optimized during the training to minimize the loss function. The layers can be grouped as input layer, hidden layer, and output layer. Input layer has the job to pass the input vector to the neural network. If we have a matrix of 3 features, that is shape n into 3, this layer takes 3 number as the input and passes the same 3 number to the next layer. Now come to hidden layer. It represents the intermediary nodes. They apply several transformations to the numbers in order to improve the accuracy of the final result. And the output is defined by the number of neurons. Now, third layer is output layer. That returns the final output of the neural network. If we are doing a simple binary classification or regression, the output layer shall have only one neuron. So it returns only one number. In the case of multi-class classification with 5 different classes, the output layer shall have 5 neurons. The simplest form of ANN is the perceptron. That is a model with one layer only, very similar to linear regression model. Let's say we have a data set of n rows, 3 features and 1 target variable, that is binary 1 or 0. I put some random number between 0 and 1. That is, data should always be scaled before being fed into a neural network. This is input and that is the output. Just like in every other machine learning use cases, we are going to train a model to predict the target using the features row by row. Let's start with the first row. What does training a model mean? It means searching for the best parameter in a mathematical formula that minimizes the error of your prediction. In the regression model, that is linear regression, you have to find the best weight. In tree-based model, that is random forest, it is about finding the best splitting points. Usually the weights are randomly initialized when adjusted as the learning proceeds. Here I will just set them all is 1. So far we have done anything different from a linear regression. Now here is the upgrade from a linear model to a non-linear one. Under the activation function, here activation function. The activation function defines the output of that node. There are many and one can even create some custom function. If we would set a simple linear function, then we would have no difference from a linear regression model. This is the linear function. I shall use a binary step activation function that returns 1 or 0 only. 0 if x is less than 0, 1 if x is greater than equal to 0. We have the output of our perceptron, a single layer neural network that takes some input and returns one output. It returns only one output and takes some input. Now the training of the model would continue by comparing the output with the target, calculating the error and optimizing the weight, reiterating the whole process again and again. And here is the common representation of neuron. Deep neural network. One could say that all the deep learning models are neural network, but not all the neural network are deep learning models. Generally speaking, deep learning applies when the algorithm has at least 2 hidden layers. Imagine replicating the neuron process 3 times simultaneously. Since each node, that is weighted sum and activation function, returns a value, we would have the first hidden layer with 3 output. Now let's do it again using those 3 output as the input for the second hidden layer, which return 3 new numbers. Finally, we shall add an output layer, that is one node only, to get the final prediction of our model. Remember that the layers can have a different number of neurons and a different activation function. And each node weight are trained to optimize the final result. That's why the more layers you add, the bigger the number of trainable parameters get. Now, you can review the full picture of neural network. Please note that in order to keep it as simple as possible, I have not mentioned certain details that might not be of interest to the business. In particular, bias. Inside each neuron, the linear combination of input and weight include also a bias, similar to the constant in a linear equation. Therefore, the full formula of neuron is summation xi into wi plus bias. Backpropagation. During training, the model learned by propagating the error back into the nodes and updating the parameters, weight and biases to minimize the loss. This is the backpropagation. Gradient descent. The optimization algorithm used to train neural network which find the local minimum of the loss function by taking repeated steps in the direction of steepest descent. Model design. The easiest way to build a neural network with Tensorflow is with the sequential class of Keras. So a model with only one dense layer, it is the most basic layer as it feeds all its input to all the neuron. Each neuron providing one output. The name perceptron. This is a fully connected layer with 3 features as the input and 1 node, because we want one output. Here total parameters are 4 trainable parameters and non-trainable parameters are 0. The summary function provides a snapshot of the structure and the size in terms of parameter to train. In this case we have just 4, means 3 weight and 1 bias. Let's try to move from the perceptron to a deep neural network. Probably you are going to ask yourself some question, that is how many layers? The right answer is try different variants and see what works. I usually work with 2 dense hidden layers with dropout, a technique that reduces overfitting by randomly setting input to 0. Hidden layers are useful to overcome the non-linearity of data. So if you don't need non-linearity, then you can avoid hidden layers. Too many hidden layers will lead to overfitting. How many neurons? The number of hidden neurons should be between the size of the input layer and size of the output layer. That is number of input plus 1 output divided by 2. What activation function? The most used one is ReLU, that is rectified linear unit. This is a piecewise linear function that returns the output only if it is positive, and it is mainly used for hidden layer. Besides, the output layer must have an activation compatible with the expected output. Zero if x is less than equal to 0, x if x is greater than 0. Logistic sigmoid, sigma x equal to 1 by 1 plus e की power minus x. I am going to assume an input data set of n features and one binary target value. Here n features equal to 10 model, name deep NN, that is deep neural network, hidden layer 1, dense layer, dropout. Here total parameters are 91, trainable parameters are 91 and non-trainable parameter is 0. The model class gives more flexibility and control over the layers, and it can be used to build more complex model with multiple input or output. There are two major differences. The input layer need to be specified while in the sequential class. It is implied in the input dimension of the first dense layer. The layers are saved like object and can be applied to the output of other layers. This is how you can use the model class to build our perceptron and D and N. In this, we can use the model class to build our perceptron and D and N. Visualization is our best. I prepared a function to plot the structure of A and N from its Tensorflow model. Here is the code. Tensorflow provides a tool for plotting the model structure as well. You might want to use it for more complex neural network with more complicated layers. Sometimes it is a bit tricky to set up. Thank you.